Alrighty. If you are, this is the last part of the first example question. If you just came here on the warpath, like, gee, I really don't get those answers. It's because I'm so sorry about this. This had a typo. It was 0.79 on the thing I sent you. It really should be 7.90. I thought I'd make like a big radius. Okay, but apparently I didn't believe it, so I didn't type it. But I'll do this. I'll solve this problem. That probably is enough to help you out, right? But anyway, there it is, right? So this is one of these ones where we're going to do F equals ma first, get the acceleration, then find the period. And then with the acceleration, find the force at the bottom, right? So one of the things we've got to do is we always have to figure out the weight, right? So the weight is mg is 2.6 times 9.81. Okay, so we're always doing that. Okay, so 2.6 times 9.81. I'm going to store that in W just for kicks. 25.506. Okay, and then here is this nice circle here, right? At the top, we've got a force of 12.3 up. Okay, what that means, by the way, is that this acceleration must be one of those ones that's less than 9.81, because we have to actually prop that thing up to keep it from accelerating down. Okay, now gravity is always, acting down, right? So that we have another force of gravity acting on this thing, 25.506. That's going to act down like that. And the first thing we're going to do is figure out the acceleration of this, right? So that's positive, that's negative. Positive 12.3 minus 25.506. Let's figure this out. Oh, that equals 2.6 times A. Okay, so parentheses, 12.3 minus the weight. Okay, right parenthesis divided by 2.6. And I'm getting that the acceleration is negative 5.07923 meters per second squared. Okay, so that the acceleration, then the centripetal acceleration, is just 5.07923 meters per second squared, because this thing is accelerating toward the center. It's accelerating down. That's why it's negative at the top. Okay, so we want to figure out the period. To figure out the period, we're going to use the formula. Centripetal acceleration is 4 pi squared r over t squared. Right, so that's going to be 4 pi squared. And then here's where it helps to have the right radius, 7.9 over, we don't know t, right? T squared. And then we know that that equals this guy here, 5.07923. Right? Okay, so we just set this thing up. We know what the acceleration is. We're just solving for t. So let's do that. That's going to be... it's actually going to be this times this times this divided by this, and then square root to get this. So we go 2 times pi times the square root of, what's it going to be? It's going to be r over a, isn't it? So 7.9 divided by, oops. Let's see. Oh, there we go. Okay, this is good. I typed the wrong letter there. Okay, so I've got that answer in there. And I'm getting that this t is equal to 7.836 seconds, which I guess would be close to 7.84 seconds. Right, that's supposed to be an S, not a 5. The next digit's a 0, actually, a bunch of zeros. Okay, so that's our period. So basically for this thing, use F equals ma to solve for A, use the absolute value of that, right, as your centripetal acceleration, and then use some formula. Sometimes they ask for velocity, sometimes for period, right? Why not, right? And then it says, what about the bottom, right? What force and what direction is required at the bottom? Okay, and so at the bottom, we're going to be accelerating up at this rate, right? Okay, the gravity will still be down, right? So we've got some unknown force, right? Minus gravity, 25. right? And now we know the acceleration is 2.6 times. And at the bottom, since you're accelerating toward the center always, right, the acceleration will be positive. So we're just going to slap a positive sign on that. Positive 5.0723, right? 70923. There we go. Yes, there we have it. Okay, so now when we do this, we're going to go 2.6 times this. 2.6 times 5.07923. Okay, and then we're going to add that plus the weight. I get 38.7. Yeah, that's what we're supposed to get. Newtons, and that would be up. At the bottom, it's never any dilemma, right? At the bottom, you always have an upward force, but you still need to say which way it is because I ask you to. All right, I think we're good. Are we good? Maybe I'll put one more of these up on the website, and that'll be good for us. All right.